Hello everyone, welcome you all to the GATE lecture series, Networks, Signals and Systems. Myself Dr.M.GOMATHI, Assistant Professor, Department of ECE, SA Engineering College. So today's session we are going to discuss about mesh analysis. So what is mesh? So in circuit analysis, loops and nodes are very important concepts. Loop is nothing but any closed loop or any closed path is considered as a loop. And what is node? Node is nothing but two or more circuit elements connected together which forms a junction point is called as node. And then mesh. So mesh is nothing but it is a loop which doesn't contain any inner loop. So in mesh analysis we are going to define the meshes, and after defining the meshes we are going to find the current flowing through the circuit. So what is mesh analysis? Mesh is one of the important methods for solving network theory problems. So it is a process to calculate the current flowing through a circuit. And what is super mesh? Super mesh is nothing but when the current source is shared between two nodes. So when the current source is shared between two nodes, then it is considered as a super mesh. So in order to calculate or determine the current and voltage, we use Kirchhoff's voltage law and current law, whereas Kirchhoff's voltage law is applied in mesh analysis and Kirchhoff's current law is applied in nodal analysis. Whereas in voltage law we calculate or we determine the current in each loop, and in current law we determine the voltages at each node. In short, we can also define as whereas Kirchhoff's voltage law, whereas voltage rise is equal to voltage drop, and in case of current law, incoming current is equal to outgoing current. So coming to Kirchhoff's voltage law, the statement for voltage law is, it states that the algebraic sum of the potential difference in any closed surface must be equal to 0. That is, we can also define as voltage rise is always equal to voltage drop in the circuit. So what is the procedure to solve the mesh analysis? So the steps are, the first one is identify the total number of meshes. First we have to identify how many closed loops are there in the given circuit. After identifying the meshes, we have to assign the mesh current. So how many closed loops are there? That many current we have to define, such as I1, I2, I3, etc. And next one, after assigning the mesh current, we have to write the KVL equation by using Kirchhoff's voltage law. By considering KVL, Kirchhoff's voltage law, we are going to write the equation for each and every mesh. After writing the equation, we are going to solve the equation either by equation method or by matrix method in order to find the individual mesh current. So let's move on to the problem. The first problem, in the network shown in the figure, determine the branch current by using mesh analysis. So this is the given circuit which consists of 100 volt source and one 10 amps current source, and this current source is parallel with this 10 ohm resistor, so that we can simplify the circuit so that it will be easy to find the current. So since it is parallel, this 10 amps current source is parallel with 10 ohm resistor, we can simplify this, we can convert into a voltage source by using this formula. So by using Ohm's law, V is equal to IR. So V is equal to the current source. I is nothing but 10 amps and R is nothing but the resistor which is parallel to this 10 ohm resistor. It is 10. So 10 into 10, which is nothing but 100 volt. So the entire this 10 amps and 10 ohm resistor can be replaced as a 100 volt source. So we have replaced it. So 100 volt source, and we have a remaining circuit elements such as resistors and then another voltage source. So after redrawing the circuit, we are going to the first step. We are going to follow the procedure. The first step is we are going to define the mesh. So meshes is nothing but any closed loop is considered as a mesh. So considering this circuit, we have three closed loop. So first loop, second loop and third loop. So after considering the loop, after finding the loop, we are going to assign the loop current. So for the first loop, I am assigning the current as I1, for the second loop I2, and for the third loop I3. So this is the second step. So follow the third step. After defining the mesh current, we are going to write the KVL equation for the individual loops. So applying KVL for loop 1. So as we discussed, the algebraic sum of the current should be equal to 0. That is, voltage rise is equal to voltage drop. So considering the first loop, the voltage rise is nothing but 100 volt, which is equal to, what are the drop? The voltage rise is nothing but 100 volt, and drop is nothing but the drop across 15 ohm resistor and the drop across 20 ohm resistor, which is nothing but 15 ohm, which is present in the loop 1 alone, and it is not shared between loop 1 and loop 2. So I am writing as 15 into I1, and considering this 20 ohm resistor which is present between loop 1 and loop 2, so that we are writing as 20 into, now we are writing for I1, so I1 minus I2. So multiplying this 15 I1 plus 20 I1 minus 20 I2, which is nothing but 35 I1 minus 20 I2. So this is the KVL equation for the first loop. And writing the equation for the KVL equation for the second loop, since for the second loop we doesn't have any source, so I am writing as 0, that is voltage rise is 0, and what are the voltage drop is nothing but drop across all these three resistors, 5 ohm, 20 ohm and 30 ohm. So 5 into I2, and 20 ohm is present between I2 and I3. So now we are writing for I2, so 20 I2 minus I1, and this 30 ohm which is present between loop 2 and loop 3, so 30 into I2 minus I3. So after solving this, 20 I2 minus 20 I1 plus 30 I2 minus 30 I3, so after adding all these three we get, whereas the voltage rise is 0, which is equal to minus 20 I1 plus 55 I2 minus 30 I3. So this is the KVL equation for loop 2. And writing the KVL equation for the last loop, whereas the last loop which consists of a voltage source, whereas the voltage rise is 100 volt and drop is nothing but the drop across 55 ohm resistor and 30 ohm resistor. So writing the equation for this, the voltage rise is 100 volt and the drop is 5 into I3, and 30 ohm resistor is present between I3 and I2, so 30 into I3 minus I2. So solving this equation we get the voltage rise is 100, which is equal to minus 30 I2 plus 35 I3. So solving all these equations, these three equations, that is 3 mesh current equation, solving all these three by using matrix method, we get the delta value as 21875, and then the current value I1, the replacing the matrix by the source value, whereas I1 equal to 1.942 amps and I2 is nothing but minus 1.6 amps, and I3 which is nothing but minus 4.285 amps. So this is about your first problem, finding the loop current. Since we have 3 loops, we have find out 3 currents, I1, I2 and I3. So moving on to the second problem, using mesh analysis, find the current I1, I2, I3 and evaluate the power developed in the 10 volt voltage source. So see the circuit. So this is the circuit where we have, the first step is we have to define the meshes. Since we have 3 closed loop, so we have 3 meshes. After defining the meshes, we have to define the mesh current. So 3 loops, I am defining 3 current, I1 and I2 for loop 2 and I3 for loop 3. So analyze this circuit. Since we have a 2 amps current source in between I1 and I2. As we discussed earlier, when the current source is shared between 2 loops, then it is considered as a super mesh. So now this 2 amp source is present between I1 and I2. So this entire circuit is considered as a super mesh analysis. So moving on to the first step, since we have the 2 amps current which is present between loop 1 and loop 3, so the entire loop, that is 1 and 2 combined together, it is considered as a super mesh. So applying KVL to this entire super mesh, whereas I1 and I3, this entire mesh is considered as a super mesh. Applying KVL to this entire super mesh, we have the voltage rise is nothing but we have 2 voltage sources. One is 12 volt and next one is 10 volt. Considering the direction, so 12 volt, and then considering the I3 current, I3 direction, it is from plus to minus, so that it is minus 10, which is equal to 4 into the drop across 4 ohm resistor. 4 is present between first loop and the second loop, so 4 into I1 minus I2, and the next 6 ohm resistor is present between I3 and I2, so that we are writing 6 I3 minus I2. So solving this equation, we get the voltage, the voltage rise across the super mesh, which is 2, which is equal to 4 I1 minus 10 I2 plus 6 into I3. and considering the current sources alone, so we have two sources, that is we have 12 volt and 10 volt. Considering these super mesh alone, the current which is flowing in the super mesh, which is nothing but I3 minus I1, which is equal to 2 amps. So considering the direction, one is coming from forward direction, that is up to down, and the I3 direction is from down to up, so that we are writing I3 minus I1, which is equal to the value of the current source is 2 amps. So considering the current source which is shared between the two loops alone, we are writing the equation I3 minus I1, which is equal to 2 amps. And considering the third equation, that is considering the loop 2, that is mesh 2, we are writing the equation as, that is considering this loop 2 alone, the voltage rise is nothing but 2 volt and the voltage drop is across 2 ohm resistor, 4 ohm resistor and 6 ohm resistor. So that we are writing 6 into 6 is present between the resistor is present between loop 2 and loop 3, and the 4 ohm resistor is present between loop 2 and loop 1, and 2 ohm resistor is present only in the loop 2. So considering all these current source, after reducing it, we get the voltage rise is 2, which is equal to minus 4 into I1 plus 12 into I2 minus 6 into I3. So this is the third equation. So solving all these three equations, that is I1, I2 and I3, we get I1 is equal to 1 amps, I2 is equal to 2 amps and I3 is equal to 3 amps. And in the given question, it is given that find the power, evaluate the power developed in the 10 ohm source, that is 10 volt voltage source. What is the power developed across this 10 volt voltage source? Since this 10 volt source is present in the which loop, means it is in the present in the third loop. So the formula for power developed is, power is nothing but it is the product of voltage into current, and the voltage present in that particular loop is 10 volt, and the current which is developed across is in the third loop. We found that the current flowing in the third loop is 3 amps. So 10 into 3, which is nothing but, we get the power across this loop is nothing but 30 volt. Thank you all. We will discuss the remaining concepts in the next class.